Good morning, mathematicians. Mrs. Post here. Today is Tuesday, April 14th, and we're going to continue our work on simplifying radical expressions. We're going to work on operations with division. So yesterday we worked on multiplication. I'm going to go over yesterday's problem real quick, and then I'm going to show you how to work on them whenever we are dividing. So let me go over to yesterday's problem. It looked like this. And so this was the U-try problem you all had yesterday. So a lot of you guys had questions about the variables. So I'm just going to quickly show you what it should have looked like. So hopefully you guys would have multiplied your, they're kind of like coefficients, your 2 times your 5. And you would have brought everything together using your product property of radicals. So you would have had your 18a cubed, and you would have multiplied that by your 72a squared b cubed. And you know that 2 times 5 is 10. And on the inside, a strategy that I was hoping some of you guys would have done would be to multiply 18 times 72. And if you were to do that on your calculator, you guys would have gotten 1,296. So 1296. And then you would have brought together your a's. So a cubed and a to the second power, when you multiply variables or numbers with the same base, you add your powers. That's a to the fifth power. And then you would have just had b to the third. We just brought that down. Now, here's what I was hoping you guys would do. When you square root 1296, or if this is a cube root or a fourth root or whatever kind of index you have here, hopefully just check and see if it's perfect. And if you were to do that on your calculator, just check. I always recommend that you check. It actually is a perfect square. It's actually 36. So if you were to calculate that on your calculator, hopefully you would have checked that out and just given it a check, because that would make your life so much easier. When that happens, you can remove the number, the constant, and all you'd have left would be a to the fifth b cubed inside your radical. Okay, that definitely should make your life a little bit easier. So 10 times 36 is 360. And another thing I wanted you guys to kind of look into doing, and I know this is where some of you guys are gotten stuck, because a to the fifth is not a perfect square. B to the third power is also not a perfect square. Remember, this is an index of 2. This is just a regular square root. That means you need to pull out groups of 2. So I know that a to the fifth is the same as a squared times a squared times a, right? Because you have 5 a's. So a squared times a squared is a to the fourth, and then another one would give you a to the fifth. And then you have 3 b's. And hopefully you guys remember, you have squared here. You have a regular square root, so you're looking for powers of 2. You can rewrite b cubed like b squared times b, because then that's b to the first power. And 2 plus 1 is 3. So it's the same thing. This to here is equal. We're just rewriting it a different way. So hopefully you guys are catching, you have a set of a's here, a set of a's here, and a set of b's here. Right, and you're going to have one left over. You're going to have a leftover A and a leftover B, because there are not 2 of them. Because once again, this is a index of 2, or just a regular square root. So hopefully you guys would have simplified this as 360. The square root of A squared is A. The square root of A squared is A. And the square root of B squared is B. And what you would have had left inside would be that single A and that single B. And then you guys can go ahead and just combine everything. 360 a squared b times the square root of ab. And that's what I was looking for yesterday. So I know a lot of you guys are able to get the 360, but remember, if you have a power of 5 and you're looking for a square root and it's an odd and you have an even index, you probably are going to have one left over. Okay, so that's what I was looking for yesterday. If you have any questions, feel free to ask me about it today, or you can pause the video and look over this a little bit further. So I'm going to go ahead and go over your notes for today. I told you that we were going to work on dividing these radicals. So the number one rule, there's a bunch of rules, but the number one rule is to remember that there are no radicals in the denominator. Okay, so you guys are looking at this stuff right here. You cannot have a radical in the denominator, just like you can't have a 0 on the denominator with a fraction. You cannot have a square root, a cube root, a fourth root. You can't have a radical symbol in your denominator. So in order to avoid that, you have to do what we call rationalizing the denominator. Okay, you have to mess with it, and rationalize is like a verb. You have to mess with your expression. So in order to do that, it says you multiply the numerator and denominator by a quantity so that the radicand has an exact root or perfect power. So you're trying to make it like a perfect square or a perfect cube or a perfect whatever. So you'll end up with no radical in the denominator. Like down here, you have a 2 down here. Okay, so your goal is to, like, for example, if you had this problem right here, the power of 3 divided by the power of 2, you can't have this power 2 on the bottom. You cannot have that. So because the rules say no radicals in the denominator. So how do you fix it? You rationalize the denominator. So whatever you have down here, you can multiply it by that exact same term, and you can get it to cancel out, basically. So, and that's not necessarily always true. You may have to multiply it by a different number, but you're trying to see, okay, what can I multiply this square root of 2 by to get it to become just a regular number? And so just right here, hopefully you guys are seeing, okay, well, if I have a square root of 2 and I need it to become a regular number, what if I multiply it by another square root of 2? Because I know the square root of 2 times the square root of 2 is the square root of 4. What's the square root of 4? 2. That's what you're looking for. So you're trying to figure out what can I do to bring it down to a regular constant, just a regular number. And remember the rules of algebra, you can do whatever you want. Just make sure that whatever you do to one side, you do to the other. So in this case, if you do it to the denominator, make sure you also do it to the numerator. So if you multiply, in this case, the numerator, which is the square root of 3, times the square root of 2, that gives you square root of 6. And that's okay. You can have a radical in the numerator, you just can't have one in the denominator. And you're all good to go. All right, we're going to do a couple more of those. So just a couple of reminders about the steps. Whenever you have an expression, you're welcome to use the quotient property of radicals, which is same as the product property of radicals, where you can have a radical, and you can have two separate ones, and as long as your index is the same, you bring them together. All right, and I'll show you how to do that with a couple of examples. And same thing if you have two separate radicals, you can bring them together, or if you have one large radical, you can also separate them, and I'll show you how to do that with a couple of examples. And just always check your power. Is it a power 2? Is it a power 3? Check your index and try to rewrite them into the same kind of power, okay? And then rationalize if necessary. So let me go ahead and show you what I mean with a couple of examples. So here's the first one I have for you guys right here. All right, and I expect you guys are writing these down. So here's an example of that quotient property. This is just with variables, just to kind of show you. Let's say you have by b, so it's the nth root of a over b. You can rewrite this as the nth root of a divided by the nth root of b. So that's just what the quotient property means. It means if you have like one radical symbol, you can break it into two, or you could do the reverse. If you had two, one on the top, one on the bottom, you could bring them together and just have one. And I'll show you different scenarios when you want to use them. So it's just a kind of a tool to use. All right, so that's your first example. That was a quick one. Here's your example 2. So let's say you have the square root of 27, and you also have the square root of 3. Now, you cannot have a radical on the bottom, we know that, but using the quotient property, what you can do is you can bring them all together. So you can say, okay, well, I'm going to make a large radical symbol, and I'm going to do 27 divided by 3. And what's 27 divided by 3? Well, that's 9. What's the square root of 9? Well, that's 3. And that is a time whenever that quotient property is really, really helpful. Okay, so that's the time when that quotient property is really, really helpful whenever you have two radicals. All right, and let's do some more. Let me see if I can do this. Well, I kind of knew that was going to happen. All right, now let me do an example 3. And I'm going to move this around for you guys. Hang on just a second. Okay, so I fixed my cursor. Here's your third example. So let's say now we're going to work on a cube root. And same rules apply. So let's say we have your numerator as x to the 6th and your denominator as 8. So using the quotient property, you can go ahead and write them separately. So you can use the numerator as x to the cube root as x to the 6th and the denominator as the cube root of 8. So since your index is 3, you're trying to get everything to a power of 3. So I can do that. We can do this. We can write x to the 6th. 6 divided by 3 is 2. And we can make this x squared to the power of 3, right? Because this is an x squared times x squared times x squared, x to the 6th power. It is. We talked about this a couple weeks ago. And I can also write my cube root of 8, it actually is a perfect cube, as 2 cubed. Because 2 times 2 is 4, 4 times 2 is 8, right? 2 times 2 times 2 is 8. So this actually works out really, really well, because once we simplify, you can go ahead and remember those are going to cancel. You're going to end up with x squared on the top, and your denominator is going to be 2. And that is okay to do because you have a 2 on the denominator and it is not a radical. So you are fine. These are all fine. These are some basic examples of how the process works. Now, remember, you may have some more complicated problems, and that's okay. I have a couple more examples for you. I think I have 2 more. All right, you have example 4. All right, so this is where we're going to have to start rationalizing the denominator, so be on the lookout for these. Okay, so here's my first example. This one just has variables. So we're going to set this up as a basic square root, and you're going to have, this is just a variable, d to the 12th power over into the 9th power. Okay, sorry, I have my notes right here. All right, so you have d to the 12th and into the 9th. So this is a basic square root. So remember, you're going to go ahead and rewrite them as powers of 2. But let's go ahead and use the quotient property first and just go ahead and set this numerator up as d to the 12th. And you can set the denominator up as the square root of into the 9th. All right, now you can go ahead, because remember we're following these steps up here. Use the quotient property to kind of separate them or bring them together, whatever is easier, whatever works for you. And then factor them into power of 2s, power of 3s. Remember, this is a power of 2. This is just a basic square root, right? So we're looking to rewrite them with a power of 2. So I know 12 divided by 2 is 6. So if I have d to the 6 2 times, that's d to the 12th. Do the same thing with n to the 9th. This one's going to be a little more funky because n to the 9th, it won't divide by 2 evenly, so I'm going to have some leftovers. So what I would do, if I were you, I would look at it like this. I would take 1 away from the 9 and look at it kind of like this, right? Because n to the 8th times n to the 1 power, that's n to the 9th. It's the same thing. It's equal to, so we're not changing the value, we're just rewriting it. When you do that, hopefully you guys will see that I'm not going to mess with the top right now. I'm just going to leave it the way it is because it's fine. But I'm going to mess with that bottom a little bit. So kind of think, okay, n to the 8th. 8 divided by 2, just like we did 6 divided by 2, or 12 divided by 2 is 6. 8 divided by 2 is 4. So n to the 4th 2 times. That's n to the 8th. But we got that extra one. I'm just going to bring him out over here. So now it works out really, really well. Now I have a power 2 and I also have a power 2. One on the top, one on the bottom. So I'm going to bring this down. My d to the 6 squared, so the square root of d to the 6 twice is going to be d to the 6th power. And my square root of n to the 4th twice is going to be n to the 4th. But the stinky part is that we've got this guy right here. He's still stuck inside the radical. So look at that. See how you have a square root on the denominator? You can't have that. So remember the rules are to rationalize the denominator by multiplying by pretty much whatever you have to do to get rid of that. We can't have a radical on the denominator. So what you're going to do, and I'm just going to try to change my color here. It's not going to let me do it. I'm going to try to change my color if I can, as best as I can. I can't do that. All right, let me see if I can change that. change it here. Try it here. Multiply. That's not going to work. Oh, goodness. All right. So let's say I multiply here by the square root of n. And I multiply the top also by the square root of n, because remember, whatever you do to the top, you have to do the bottom, or whatever you do to the bottom, you have to do to the top. So when I do this, my numerator becomes d to the 6th times the power, times the square root of n, but my denominator becomes n to the 4th times the square root of n times the square root of n, which is n squared. So basically that's n to the 4th times n. And then right here you have d to the 6th times the square root of n, because whatever you do the top, you have to do the bottom. Whatever you do the bottom, you have to do the top. So I want you guys to remember, this is the square root of n squared. And the square root of n squared is just n. So when we did that, we got rid of our radical. So now really what you have is d to the 6th times the square root of n up top, and your bottom just becomes n to the power of 5. And that's your final simplified radical. A little messy, but that's the point. The point is to get rid of the radicals on the bottom by multiplying basically by itself. If it's a square root, if it's a cube root, you may have to multiply it 2 more times, two times. But I'll show you an example where that is. If you're not quite sure how that happened, you got to look over this. Your assignment for today also has some more examples of rationalizing the denominator. So when you guys look at your assignment for today, you'll see some more examples. You guys are welcome to go to the online textbook. You're also welcome to Google it. But this is my last example for you because I'm already at 16 minutes on our video. My last example is, let's see, I'm going to give you guys a cube root for this one. It is a cube root of, let's see, I've got 9 on the top and 2m on the bottom. It's a cube root. So we have a cube root of 9. 9 is not a perfect cube. And a cube root of 2m, also not a perfect cube. So we can't simplify anything because factors of 9 are just 3 times 3. There's not a set of 3. And 2m is just 2m. I don't have 3 numbers or 3 variables that I can reduce to get rid of the radical. So we're kind of stuck the way we are. So what do we do when that happens? We get rid of the bottom. We get rid of the radical on the bottom. Because it's a cube root, that means we need 3 of the same thing, right? Square roots mean you need 2 of the same thing. Cube root means you need a set of 3. So we need 2m 3 times, right? We have 2m, 2m, 2m. Yeah, so about this video, this is the third or fourth time I've tried to record this, and my computer crashes every time. So hopefully this 4th time is a charm. So anyway, let's go back over here and let's think about that process. So just like I told you guys, we need to go ahead and multiply it to get rid of the cube root. So I'm going to multiply the top and the bottom. So that means I need to multiply by, I need 3 2s. I already have 1. I need 2 of them now, 2 more. Because if you look at it now, I'm going to have 3. 1, 2, 3. I already have 1 m. I'm going to need 2 more m's. So when we multiply them out, hopefully you guys will see here that when I bring them together, I'll have 3 m's and 3 2's because I'm using an index of 3. Whatever you do to the bottom, you have to do to the top. So I hope you guys notice that really what we did was you multiplied by 4m squared, right? Isn't this 4m squared? So whatever you do to the bottom, make sure you do to the top. Now, I'm just going to finish this out and bring it down to the bottom. So now I've got numerator is, let's see, we have a cube root of 9 times the cube root of 4m squared. That's our numerator. And your denominator is going to be cube root of 2m times the cube root of 4m squared. So whatever you do to the bottom, you do the top. All right, so now you can multiply them. So the cube root of, that's going to be what, 36m squared? And that's okay. I don't see a perfect cube up there, so that's okay. And then my denominator is going to be a cube root of 8 or in this case, 2 times 2 times 2, m times m times n, right? 8m cubed. That's a perfect square. Look how cool that is. So the cube root of 8 is 2. Cube root of m cubed is m, and my numerator is just the cube root of 36m squared. And that is it. We followed the rules. So the trick is to rationalize the denominator. That is the trickiest part of today's lesson, rationalizing the denominator. So if you guys need help today, you're going to have to send me your notes. Show me that you actually took these notes, wrote them in your notebook, and sent them to me. I wrote them out here. I made a video about it. I wrote them on the board, so I expect you guys to do at least that much work. Once I see that you've had all these examples written down into your notebook, I would like this turned in, as well as today's assignment, which is, hopefully I have it over here. I don't think I do because I've had to shut down my computer. Oh, there it is. So many times today. And restart it. All right, there it is. That's today's assignment. I'm not exactly sure which page this is in your green workbook, but it does come from there. So it is lesson 6-5. So you can look for it in your green workbook and you don't have to download it. You can just look at it in there and it shows you how to rationalize the denominator. And so there it is right there. So it shows you how to do that. But there's just 6 problems. 1, 2, and 3 were from yesterday's lesson. So you can continue on practicing with those. And 4, 5, and 6 are division, just like these. And I believe you have to rationalize those every single time. So you will have to rationalize 4, 5, and 6. So you guys are practicing this. This is a practice assignment. I'm telling you this. This is your math teacher telling you. If you do not practice it, you will struggle on the exit ticket this week and on the assignments for next week. You will have a 5-point exit ticket this week. Please make sure you guys are reading the newsletter and looking over what will be due. I do expect you to do your work today. I know there's a little bit of a delay because of the video and the tech issues, but I'll work with you guys. You guys work with me. All right, work on your mathematics, and I'm here if you guys need me, and I will talk to you later. Hopefully you guys look at this video soon. All right, bye guys.